Hi, I'm Frank David from the biotech consulting firm Pharmagellan, and this is the second video in a series about time-to-event studies and Kaplan-Meier curves in biotech. In this episode, I'll give you a math-light guide to the numerical outputs from these trials. If you've gone to a medical meeting or read a journal article where one of these studies has been presented, you've probably seen a set of summary data in the corner, like in these examples. So the questions we'll address in this video are, what numbers are you likely to see in the data box, and how should you interpret them? Before we get started, two quick points. First, as I said, this is a math-light video, so you don't need to break out your calculator. It might be a little basic for experts in clinical development or biostatistics, but investors, bankers, med affairs, and marketing folks, you should all be fine as long as you have some experience reading drug companies' press releases and presentations. However, to get the most out of this, I recommend you first watch the prior video in this series if you haven't already. Second, if you like this video on time-to-event studies and Kaplan-Meier curves, check out the other episodes in the series, as well as our free white paper on interpreting study results and our top-notch handbook for non-experts, the Pharmagellan Guide to Analyzing Biotech Clinical Trials. Look in the video description and on the Pharmagellan website for details. Okay, let's get started talking about numbers in time-to-event trials. The main statistic that's relevant here is the hazard ratio, which is the ratio of the risk of experiencing an event in the experimental arm compared with the risk on the control arm. A hazard ratio of 1 means the two arms had equivalent outcomes. A hazard ratio less than 1 means the experimental drug worked better than the control, and a hazard ratio above 1 means that the control arm was better than the new therapy. To better understand what a hazard ratio means, let's return to an example from the first video in this series. Here's the event curve and results summary from Amarin's phase 3 REDUCE-IT study, which tested Vascepa versus placebo for preventing major adverse cardiovascular events. The reported hazard ratio was 0.75, which means that the risk at any given time of experiencing an event while taking Vascepa is 75% what it would be on placebo. Sure enough, that seems to fit with the figure. At 3 years, it looks like the ratio of events between Vascepa and placebo is about 12% to 16%, or 0.75. And at 5 years, it looks like just under 20% to just under 25%, which is also about 0.75. Most time-to-event studies will also report some sort of statistical significance for the hazard ratio. This is often reported as both a 95% confidence interval and a p-value, although occasionally you'll see just one or the other. You can easily interconvert between the two, although we're not going to go through the math here. For me, if I get both pieces of information, I think the 95% confidence interval is more useful because it gives me a clearer sense of how close the hazard ratio is to crossing 1, which would indicate no difference. So in this case, the hazard ratio's 95% confidence interval ranges from 0.68 to 0.83, which is pretty convincing evidence in favor of the reported hazard ratio of 0.75, because 0.83 is quite far from 1. Time-to-event studies also provide information to help you assess the absolute numerical advantage of the drug over the control, and not just the relative improvement. The paper on the Vascepa trial says that 17.2% of the patients in the Vascepa group had events over the course of the study, compared with 22.0% of the patients in the placebo group, and the absolute difference of 4.8% is what's reported here as the ARR, or absolute risk reduction. Similarly, in the Kaplan-Meier curve of a pancreatic cancer study shown here, we see that the hazard ratio for overall survival of 0.60 corresponded to a median survival of 19 weeks in the control arm versus 26.1 weeks in the arm that got the experimental drug Ariaspace. That's a benefit of just shy of 2 months. These sorts of data provide some context around how much any individual patient is likely to benefit from the new therapy. For example, the Vascepa trial specifically included moderate to high-risk patients, and I bet most of them and their doctors would see a 22% chance of having a serious cardiovascular event over 5 years as pretty high. They might be fairly enthusiastic about the prospect of reducing that risk to about 17%. But in a lower-risk population, we might have seen the same hazard ratio, but with a risk reduction from 2.2% to 1.7%. That absolute benefit of only a 0.5% decrease in events might not have been viewed as very impressive by those patients, given their already low risk. Similarly, in the pancreatic cancer study, there's no question that 26.1 weeks is longer than 19 weeks. But in order to interpret the findings, you'd want to dig into how patients and their doctors would see an average of 7 more weeks of life, especially if the new drug has additional side effects. Remember, just because a trial is statistically significant doesn't always mean it's clinically significant. The studies shown here also reported some other statistical results, like the relative risk reduction, or RRR, and the number needed to treat, or NNT. These are academically interesting and sometimes informative to practicing physicians, but in most cases, they don't add a ton of useful information to investors or folks who work in biopharma. You're usually fine focusing on the hazard ratio, the 95% confidence interval, and the absolute size of the effect. That's a wrap for this installment. If you found this video useful, please check out the 2 final episodes in the Time to Event study series on graphs and red flags. The links are in the video description. Also, make sure to download our free white paper to help non-experts interpret clinical study results. And you may also enjoy our comprehensive guide to analyzing biotech clinical trials, also intended for non-statisticians. Links for both of these are in the video description and at pharmagellan.com. Thanks for watching.